This class discusses conditional probability. We need this concept because sometimes we may have extra information on an experiment, which will affect the calculation of probabilities. The probability that event B occurs given that event A occurs is called a conditional probability. It is denoted by probability of B given A. We use a vertical bar to separate B and A in the parentheses. We call event A the given event. Usually, probability of B is not equal to probability of B given A. Because event A occurs, the total possible outcomes are different from those when we do not know that A occurs. The following formula shows how to calculate a conditional probability. It is very similar to how to calculate a probability before. The only difference is that when counting the number of outcomes, we only count those when A occurs. Let's use one example to illustrate the concept. Consider the experiment of rolling a balanced die once. Here we define two events. Event F means that 5 is rolled. Event O means that the die comes up odd. Firstly, let us calculate the probability that a 5 is rolled, or probability of F. We need to find all possible outcomes and then the outcome in F. The sample space includes 6 possible outcomes. Event F contains exactly one outcome. Therefore, the probability is P of F equals 1 over 6. Now, let's calculate the conditional probability that a 5 is rolled given that the die comes up odd. In this case, we want to calculate probability of F given O. Because event O occurs, not all possible outcomes in the original sample space are possible. We need to remove 2, 4, 6. All possible outcomes in this case only include 1, 3, 5. There are 3 possible outcomes. Event F contains only 1 outcome. The conditional probability is 1 over 3. We can see that these two probabilities are different. In the second example, because we know that the die comes up odd, the sample space is different, and therefore we get different probability. Sometimes the probability in the first example is called an unconditional probability if we want to emphasize its difference from the second example. The calculation of conditional probability appears frequently in a contingency table. This contingency table shows the frequencies for age and rank of faculty members in a university. What is the probability that the selected faculty member is in his or her 50s? This question asks for a marginal probability. We need to check the row total. There are 253 faculty members in their 50s. Therefore, the marginal probability is 253 over 1,164, which is 0.217. What is the probability that the selected faculty member is in his or her 50s, given that an assistant professor is selected? This question asks for a conditional probability. Pay attention to the word given, which hints that it is a conditional probability, because the faculty member must be an assistant professor. The total possible outcome is 320, which is the total number of assistant professors. The numerator is 36, which is the number of assistant professors in their 50s. Therefore, the conditional probability is 36 over 320, which is 0.113. Comparing these two examples, we can see that when calculating the conditional probability, both the numerator and the denominator are different. They are the numbers of faculty members when we limit ourselves to assistant professors. We want to discuss an alternative formula to calculate a conditional probability. If A and B are two events such that probability of A greater than 0, then probability of B given A can be calculated as the ratio of probability A and B and the probability of A. Notice that the denominator is the probability of the given event, and the numerator is the probability that both A and B occur. We may apply this formula to the problem we just discussed. What is the probability that the selected faculty member is in his or her 50s, given that an assistant professor is selected? Apply the formula. The numerator is probability of A4 and R3. Its value is 36 over 1,164. Notice that 1,164 is the total number of faculty members. The denominator is 320 over 1,164. This leads to the same answer as the previous slide. Now we have two approaches to calculate a conditional probability. The first one, we need to count the number of outcomes. The second one, we need to calculate the ratio of two unconditional probabilities. In practice, which one to use depends on what information is available and which one is easier. In this example, we know the joint probabilities and marginal probabilities of gender and marital status of some people. What is the probability that the adult selected is divorced, given that the adult selected is a male? This question asks for a conditional probability. The given event is that the adult selected is a male. Because we only know the joint probabilities and the marginal probabilities, we apply the formula we just discussed. The numerator is the probability that both events occur. Here, it is the probability of male and divorced, or the joint probability of male and divorced. Check the table. The value is 0.044. The denominator is the probability of the given event. It is the probability of male, or the marginal probability of male. Check the table. The value is 0.485. Therefore, the conditional probability is 0.044 divided by 0.485, which is 0.091. What is the probability that the adult selected is a male, given that the adult selected is divorced? This question also asks for a conditional probability. Compared with the previous question, we switch the order of two events. Now, the given event is divorced. Applying the formula, the numerator is still the joint probability of male and divorced, which is 0.044. However, the denominator is the marginal probability of divorced, which is 0.104. The conditional probability is 0.044 divided by 0.104, which is 0.423. We can see that when calculating a conditional probability, we need to be careful which event is the given event. Probability A given B and probability B given A usually leads to different values. Read the problem carefully. The event after the word given is the given event.